Let's talk about the real number system. We're going to talk about natural numbers, whole numbers, integers, rational numbers, irrational numbers, and real numbers. Natural numbers are also known as counting numbers. In other words, 1, 2, 3, and so on. So these are counting numbers. Whole numbers are basically counting numbers and 0. So we just start off at 0, 1, 2, 3, and so on. Integers are the whole numbers notice the whole numbers from 0, 1, 2, 3, and so on. But also we'll call those negative counting numbers as well, or negative numbers as well. Rational numbers are basically numbers that can be written as fractions, or they could be a whole number, or terminating decimals such as 3.75 or 0.986, or repeating decimals such as 0.333 repeating or 0.676767. So those are what rational numbers are. I like to think of rational numbers simply as numbers that can be written as a fraction. See, we have 1/2 here. Obviously that is a fraction. You have a whole number 3. We all know that 3 can be written as a fraction, 3 over 1. 3.75 or 0.986 can be written as fractions, and also the repeating decimals can be written as fractions. We should all know that 0.333 repeating is none other than just 1/3, or that 0.676767 is 2/3. So numbers that can be written as fractions are rational numbers. Then we have irrational numbers. They're non-repeating, non-terminating decimals, or I like to say numbers that cannot be written as fractions. Pi is 3.14 is what we know it as, but we also should know that it goes on forever. It never stops. The square root of 3, if you try to find a decimal on your calculator, you're going to get a decimal, depending on how you have your calculator set, 6 or 7 decimal places, but that does not mean that's where it stops. It actually goes on forever. So irrational numbers are numbers that cannot be written as a fraction. And then finally we have real numbers, and real numbers are basically rational numbers and irrational numbers together. So take notes over these and learn them. Next, we're going to talk about our second note card, functions and function notation. We're going to be talking a lot about functions and function notation this year. It can be kind of a complicated topic to discuss, but at the same time it can be easy. Let's just take it one step at a time. Number 1, it says function is a rule which takes certain values as inputs and assigns each input exactly one output value. Now this can be a little bit difficult. We have this little diagram here. We have an input, it has a rule, and it produces an output. I like to describe this using what I call the function machine. Here we have a function machine. Here we have the input, or where something is going to go in, and down here we'll have an output where something is going to come out. What we have inside the function machine is the rule, or the function itself. Some examples of an input value could be natural numbers, any natural number such as 1, 2, or 3. An example of a rule or a function could be f of x equals x squared, or simply x squared is the actual function. Now what we have here in this function notation, this x value here represents the input, what's going to go in. This x value over here, what's going to come out, is going to represent the output. If the 1 goes in to the function machine, it goes into the x value and 1 gets squared, and it comes out 1 squared is 1, so the output value would be 1. If 2 goes in, 2 goes in for x, 2 gets squared, 2 squared is 4, it comes out as a 4. 3 goes in, the 3 gets squared, it comes out as a 9. And so this is my basic example, what I like to use each year, of how a function works and dealing with function notation. We'll come back to this as I discuss these other numbers on the note card. Number 2, input. It's the set of numbers. Each number is used only once, domain x values. So these are the input numbers. They can also be called the domain. They're x values normally. They can only be used once. Number 3, the rule that gives the output. Okay, so this rule right here, this rule or function, is what gives the output. Number 4, the output are the answers. So this output down here were the answers coming from the rule. They're also known as the range and the y values. Function notation. Number 1, it says y is a function of x. Number 2, y is equal to f of x. This is very important right here. When you see a function such as f of x equals x squared, it's very important to know that f of x, right here it tells you f of x is y. So this can be rewritten as y equals x squared. This is simply function notation. Number 3 says the output is equal to f of the input. In other words, if you have f of x, remember x is the input, see they're interchangeable, is equal to the output, which is going to be y, which is basically the same thing I rewrote number 2. It's the same thing if you think about x being the input values and y being the output values. Y is also known as the dependent variable, and x is also known as the independent variable. So this is the independent variable. This is all review. Hopefully this is coming back to you. And y is the dependent variable. And so if we said above in number 3 that f of the input, we can also say down here that f of the independent, because input and independent are interchangeable words. They're basically the same thing. Also, output is the same thing as the dependent variable. And it says functions can be represented by words, tables, graphs, and algebraic formulas. And we'll be looking at a lot of examples of those coming in the near future.